ultimately, if Dagster is going to get used in organizations across the world, it needs to support the incredible range of things that people do. The ideal that we talk about and strive for is this notion of gradual disclosure of complexity. So simple things are easy, complex things are doable.
Hey friends, this is Podcast Ruined by Software Engineer. On this episode, I get to talk to Sandy Ryza, lead engineer at Dagster Labs, the group behind the extremely popular developer tool Dagster, which allows you to actually see all your data from one step to the other in your data pipelines. If you enjoy Podcast Ruined by Software Engineer, don't forget to hit the follow button on your podcast app so you don't miss out on the new episodes. And you can pick up podcast merch at perrytiu.com/shop. Enjoy the episode. Welcome back to another episode of Podcast Ruined by Software Engineer. I'm your host, Perry, and today with me is Sandy Ryza, leader of the Wu-Tang Clan. I'm just kidding. Lead engineer at Dagster Labs. Sandy, how are you?
I'm great. Thanks for having me on.
No, this is really the excitement of myself, of a lot of people, because this is such a topic that is technical, and especially Dagster Labs. I can't wait to talk about it. But one thing maybe that could help us to begin with is, who is Sandy, and what is Dagster Labs?
I'm the lead engineer on Dagster. I've been at Dagster Labs for about 4 years. Maybe I'll give like a kind of quick... I came out of college excited about using computers to solve hard problems and, with data. This was like in the early 2010s, so it was the age of big data and Hadoop and Spark, and I started out at Cloudera, which was, for those who aren't familiar with it, kind of the big data company at the time. We were building Hadoop and building these open source software projects, which were kind of based on architectures that Google had published for their internal tooling a couple years earlier. But the idea was to bring these concepts to the masses and allow anybody who was able to spend, hundreds of thousands of dollars on large commodity clusters of computers to process large amounts of data. And so I was working as a software engineer, working on these open source projects to help people process data. And then, I think a part of it that I was particularly excited about was machine learning. And this is before the age of deep learning and LLMs and that kind of dominance. But still a lot of people were using machine learning. I was very excited by this idea that you take like a ton of computers, some fancy math, and you build some sort of intelligence. Okay, so I was working on those tools for a little while, and it was fun, but I kind of had no idea how they were being used. I was in the world of like dealing with what's the fastest way to shuffle data across thousands of computers, which is different than like what's the best way to use an algorithm to help us understand facts about the world. And I was, very curious about the latter. So I made this jump kind of first within Cloudera by joining the data science team, and then at a set of other organizations to actually be a data practitioner. So I kind of jumped across the divide from a person making tools to being a person who was using tools. So I worked at a few different companies in a few different roles at that time. But it's kind of this, a lot of people who get hired as data scientists end up doing a lot of data engineering. So it's a bit of a hybrid data science, machine learning, data engineering set of roles at these different companies where I was, responsible for doing all the data practitioner stuff, answering questions with data, building machine learning models, etc. Somewhere in the years of doing this, I found myself frustrated because not because the work wasn't cool, but because the tooling that I kind of had to use to do the work was frustrating. So I was using these tools like Airflow. Encountering problems that sort of when I wanted to build data pipelines, nothing kind of fit in the way that I expected to. So when I would build the data pipeline, I would like draw it on a whiteboard and it would be like, okay, here's the data that I'm starting with, here's the data that I'm trying to get, and I want to think in those terms. And the tools out there did not allow me to think in those terms. So I did what I think a lot of other people, did at the time and probably are still doing, which is basically build little bits of framework wrappers around these data tools to help me do my job easier. I was doing this for myself, but also later I was leading teams and sort of trying to do this to increase productivity of the people that I was managing. From there, I got to a point where I was spending more of my time building internal frameworks to help do this job than actually doing the job itself. And when the opportunity came, I noticed that there was this very early company, Dagster. At the time, it was called Elemental, but it's now called Dagster Labs, that was trying to build a general purpose version of these kinds of bespoke tools that I had been building. So I was attracted to the mission, joined the Dagster Labs team, and have ever since then been working on this piece of software, Dagster, which is an open source data pipeline orchestration framework that allows you to think in those terms.
No, that build up in the background, everything that you're mentioning, how it kind of like ties to your, not just the frustration, but just like the curiosity and the excitement to be like, hey, look, I deal with data day in, day out. Why is my life so complicated? Trying to see exactly what data, what format, what comes in. Of course, my simple example is like a SQL query, right? Where it's like you have a bunch of raw data, and then if you do your query correctly, you aggregate correctly, you join your tables correctly, then it spits out what you want. But with Dagster Labs, I believe you could tackle much more complex cases than a single SQL query similarly to that. So, of course, we're definitely going to dive into it. And even as a side note for the excitement of why you can hear my voice, I'm so excited, a lot of it is open source. And it feels like it's something that's part of the culture, part of the identity of what you do, what Dagster Labs do at the end of the day. And we could definitely dive a little bit into how does working with a community of devs different than working with like a community of maybe like just corporate users or internal team members. So, sorry, I'm just telling off with a lot of what you said just because it makes so much sense. But that's a really good recap of maybe who Sandy is and what Dagster Labs is. But I really do like also diving a little bit deeper behind in the sense of everybody gets into tech differently. And you already mentioned the part where, data scientist. What is the difference between a data scientist versus a data engineer? What is the difference between an ML scientist or like an ML person versus like an ML engineer? I know you're smirking a little bit behind the scenes at the moment, but maybe if you reel a little bit back before all of this though, what is, I guess, home to you? What is your hometown? Where did you grow up? What did your environment look like? Did you have a lot of like techie people around you that already did this kind of thing? Or maybe just a bit of landscaping over there?
Yeah. So I grew up in Santa Monica in a very kind of non-techie environment. I went to a kind of like progressive school where we had classes that were called life skills, and the life skills that were taught were like talking about your feelings. We would like go around with a rock and like pass it around a circle. I think I got into computer science initially because liberal arts and humanities were kind of maybe a little bit more emphasized at the school I was at than kind of the math side of things. And I wanted to like, I liked math a lot. I wanted to jump ahead in math, but they were sort of like, slow down, like, that's against our policy. We don't let people jump ahead in math, but as a consolation prize, we can let you take the, intro to computer science course a little earlier. And it was this little course with like a few people, a guy who wasn't a full-time teacher. I think at the time, was he the head of the IT department at the school? I'm not sure, but he taught it on the side. But they let me take this course, and I just sort of like immediately loved it. So I don't know, it just like fit my brain. It's funny. My dad is a computer person. He wrote some software in like the 80s. But it was never really a part of my upbringing. Like, it wasn't like he taught me to program from a young age or anything like that. Like, we would maybe like work on math problems together. I feel like I kind of discovered it a little bit independently. And then I think at that point I took a fairly standard path, which is I majored in computer science in college, and then came to software engineering through that.
It's so fun to speckle, as you're saying, like whether it's your dad writing a bit of software or maybe like the fact that, hey, somebody on the side is teaching CS at I'm assuming high school-ish level, or maybe even earlier than that. That's something that I actually relate. I was in grade 9 when that happened to me, when somebody on the side was teaching. Like, it was funny because I always ask this question where it happens more common than people think about it, unless you actually explicitly talk about it and say it. But I remember that was the time when I first learned how to write my first HTML file, where they were like, yeah, just open your HTML tags, open your bodies, open your heads, and like put stuff like this and drag and drop that file onto a browser, which was obviously Internet Explorer for me back then. And boom, like it shows up. That was the moment. I remember of me being like, you could do this? You could write stuff? You could spin it in circle? Because obviously the CSS would allow you to do that. But was it similar? Because for me, it was HTML that really caught me. Or for you, was it something that they were like, oh, here's a for loop? And like next thing you're writing a for loop. What was that level, even early on, look like?
That's really funny. That actually makes me remember the thing that was right before, and so this is really gonna paint me as the nerd. I was really into Dungeons and Dragons in must have been 7th or 8th grade, and in Dungeons and Dragons you have these sheets that describe who your character is, and there's all these rules for deriving different properties of your characters from other properties. And so I started making these like complicated spreadsheets. That was, I think, even before I took this computer science class, that was kind of like the aha moment for me, where it was like, yeah, I think I didn't know about the existence of if statements, but I figured out some weird way that you could approximate an if statement using absolute value, and that was like, wow, this is pretty fun.
That's so good. I love to imagine that like a lot of it is either gaming or like just some kind of like puzzles that we're always dealing with, and that really just drive us to like be more curious about tech in general. Just because I'm assuming a lot of board games even then would just like take influences from these logics, right? But I'm not gonna ask if you're using something like Lotus Sheets or anything like that, because that's just completely way down into memory lane, if anything. But one thing that I do like asking people is, when was the first time you got access to a computer? Like the first time you got, introduced to the world of having a, personal computer, not one that is like a big mainframe, like stuck on a wall somewhere, but, just a personal computer where you get to explore things. Do you remember that?
Yeah, man. So I remember my dad telling me that telling me we were going to get a computer. I think I remember him like maybe showing me the box. It was like one of those gateway boxes. It looked like a cow pattern on it or something. And the thing that he sold me on was that we would be able to read an article about a volcano and watch a video of a volcano erupting at the same time. And that it seemed impossible that could be done. So I didn't like really put too much stock in it at the time. But that was a sell. I thought it was pretty cool. Then I got into, I think maybe a little bit after that, we got the computer. It was like the one computer for the family. Somehow someone put Doom on it, the first person shooter from like the 90s. And so I got extremely into that until at a certain point my parents were like, Sandy's like, I don't know, 7 or something. He's playing this extremely violent game, and they actually took it away from me for a while before giving it back to me when I got a little bit older.
That is such a good story. For you, it was Doom. For me, it was Diablo 1. So that was kind of like,
nice.
I guess that same vein. My parents probably like, I have no idea how we got our hands on it to begin with. So that's just how the funny story begins. Where did it come from? The machine itself, Windows, Mac, anything else that you can remember on that? I'm not putting a divide or a team or anything on it, but that's just one of those things where for me,
it was definitely a Windows machine. Yeah, I was kind of anti Mac for now I use a Mac because I like work in tech in San Francisco, but I was anti Mac for some time.
That's so good, because I feel like everybody, you were way closer to that area, if anything. For me, I grew up in Montreal, so like Montreal, we just had whatever. My dad pieced a lot of like hardware together, and even our Windows 95 barely functioned. And then next thing it was like one family computer, then we had our own, and then the rest is history after that. But
yeah, I got through college on Windows Vista, which
no way.
a lot of people try to sweep that operating system under the rug.
I'm gonna say I did. I went from XP to 7, I believe. I think that was the jump I did. That, or maybe a lot of people did.
Good for you.
We've all had our opinions on Vista, but anyways, on that, one thing that I will defend though, and also like kind of crap on, if anything, is the boring path of CS and going into just your techie job at the end. I did CS at McGill, so like in terms of boring, I get that part, but at the same time, there's like the interesting part where I'll take the example of me going into a CS program at McGill in Montreal. Is that Montreal is a quite gaming heavy industry where you have the Square Enix, you have the Ubisoft, so like they have a lot of headquarters offices over there. And this is the part where does it just means that if you did CS at McGill, you immediately go into the game industry? Like the answer is obviously no. The answer is some people got summer internships at like Snapchat, some people got internships at like Microsoft kind of thing. So even doing CS, there's like the uncertainty of like where you're gonna end up. So
definitely, I would say it was maybe a standard path, and that it's not like a super exciting story. But at the time, it felt very exciting. It felt like there were a lot of choices. Like I think the two things I went to Brown, and the two things that were big at Brown was on one hand computer graphics, which I somehow just didn't touch at all, and the other one was systems. Like there was this like famous operating system course that everyone took, and a lot of like really kind of great systems engineers came out of that. And I was a little bit more on that side, but I think I got really excited about the world of distributed systems, which were, obviously that field has been around for a long time, but it felt like it was really coming into its own at that time.
Surprisingly, I don't know if it's that common, but sometimes I have guests, obviously on the show, who have done CS. More than half of the guests have been either exposed to like computer graphics during uni or been part of like an institution that is super deep into computer graphics. I went to McGill. They're not really known for computer graphics, but I did end up doing a graduate graphics course. Do you want to hear my quick story on what I remember the most out of it?
Go ahead.
The first assignment, I don't remember the app. We were doing GL, just graphics language, and you have to write a bit of linear to print out some 3D image on that, and I got 100% on it. The punchline is I got 100% on it. The weird part about it is my submission was I coded this 3 donut shapes, one smaller than the other, and you kind of stack them on top of each other, and you put like a cone at the top, so it kind of looks like a turd. The TA absolutely loved it. It was like, looks like shit. 45 out of 45. And I was like, I love this course. I didn't do amazing in it, but it was one of the most memorable graphics course I've taken in, obviously my university career. But I don't know why I'm the one telling stories, if anything, but I'm just glad that you mentioned that Brown had an emphasis on those systems at the end. But
yeah, it seems like fun having not really done much graphics. It always seemed cool. Everyone was like competing to write the fastest ray tracer.
Yeah, exactly. Or like some shadowing or whatever they want to call it. How many edges can you throw in there? But one thing I do want to call out is a thesis. If I got this correctly, distributed combinatorial optimization. Large neighborhood search on map reduced for the vehicle routing problem with time windows.
Oh,
that
man.
sounds exciting to me. Well, I mean, not to everybody, but the thing is, when you're mentioning Hadoop, when you're mentioning a lot of the Spark, a lot of those like technology, one of my university project was on Spark. Apache Spark. We were 3 people. We were researching how it was built, what does distributed means, and all that kind of stuff. And it was funny because Hilary Duff came out with the song Spark around that time, and it was just a very like bad reference every single time.
Very topical.
But maybe from your perspective, while you were obviously on this thesis, how did that start? Was it like a capstone project where you had to do, or was it something that you were like, I really want to explore this kind of thing? Just because I feel like people are interested to hear how you actually think about a thesis, how you actually like get to go deeper on a topic that you enjoy.
Yeah, totally. So as an undergrad at Brown, you had the option of doing a thesis if you wanted to get honors or something like that. For me, I took this class that it was probably the funnest CS class I took in college. It was called Solving Hard Problems in Combinatorial Optimization. And so, when they say hard problems, it's like NP hard problems. Like an example of that is the traveling salesman problem, the knapsack problem, all that kind of stuff. And I think, there are courses that approach those kinds of problems from a theoretical perspective. So there's like proving that these problems are combinatorially hard, or like proving that you can get an approximation algorithm. But this class took this very practical approach, which I found very fun. Every 2 weeks, we would have a problem set, and the problem set was basically like a set of 1 week was the traveling salesman problem, so like a set of traveling salesman problem examples, and we had to see basically like how good a solution we could get in how little time. And the lectures, we would learn like different techniques like local search or grasp or linear programming, and none of these are guaranteed to solve these problems in polynomial time. That's impossible. But if you kind of like have the right intuition about what's going to work fairly well, you can get like pretty good solutions. And I found that kind of the kind of thing where you're doing something practical, but you can still kind of apply some degree of mathematical intuition to do a good job, very fun. So that was one kind of thread there, finding that very fun. And the second thread was distributed systems, which I was excited about kind of from this other direction. And so the question I had is, can we, these are very hard problems that require lots of computation to solve. Can we somehow use distributed systems to solve them better? And so the undergrad thesis that I did was taking a couple approaches to that and trying to figure out if there are ways that we could use distributed systems to leverage lots of compute power to like solve these kinds of NP hard problems faster. So in terms of what I actually did, what did I do? I did a couple things. The one that was maybe the funnest was using MapReduce to try to solve instances of the vehicle routing problem. And so the vehicle routing problem is like the traveling salesman problem on steroids. You have with the traveling salesman problem, you start in one place, you have to visit all these other places and do it in the shortest path. With the vehicle routing problem, you have like a bunch of vehicles. There's a bunch of places that have to get visited, but it's your job to decide which vehicle visits each place. And then each vehicle has like a capacity that it can pick up and deliver. So it just adds all these kind of crazy constraints. And then it was basically trying to figure out if we could take a solver for that and do a better job by distributing it over a bunch of commodity computers.
And you solved it. No, I'm kidding. As you're saying, like, it's one of those problems.
It's totally solved, yeah. No, I think I got like results that were like kind of interesting, but nothing, I didn't win like a Fields Medal or anything like that.
No, but I appreciate that in the sense of like, of course we heard of the travel salesman, but even the fact that I get to learn even this, the vehicle routing problem. I've heard different versions of it, but this specific one, I always enjoy when I get to like see it from other people's perspective on. It's just like an optimization problem. People are trying to make like, I don't know, Go line faster or whatever it is, but this is very similar in that sense of. Yeah. And as a side bit, if nobody has ever done CS before, I think a lot of profs just hope that one of their students end up cracking some code, end up cracking some like NP code. That's like, oh yeah, of course, duh. Like, yeah, this one of my students in my class did that.
Accidentally prove that P equals NP when solving the vehicle routing problem.
Yeah. Oh my goodness. But that is always the fun part about think about all these like, theoretical part. But I think I want to definitely get into the part where you're saying like the theory and applying it. And that really transpired when, of course, during your studies, but after your studies. The most interesting part that you mentioned, of course, is having the background in software engineering and comp sci and doing a bit of software engineering even out after school. But this transition of going into data, going into even some product management and even some like even just mentoring management, there's something that I'd like to discover. So maybe after university or even during university, any kind of like internships or any kind of more like corporate environment or opportunities that you jumped yourself into, and what did you expect going into that as like either your first real job or your first internship after studying?
Let's see. So yeah, I did a couple internships during college. One of them was at Microsoft. I was working inside Microsoft Office, and so that was like such a different experience than any other software I've worked on. Just like such a massive code base, such a, I don't know if ancient is the right word, but you can like really see the like layers of sediment that have accrued over the years. And like people have been cutting their teeth on that code base for a very long time. So that was like a fun thing to see. And then I did an internship at Cloudera, which was where I ultimately ended up actually. So I did that between my junior and senior year of college. They came to our a set of people who had done very systemsy stuff at Brown went on to work at Cloudera and then came back to do some recruiting and spread the word about it. So I thought it was cool and went to spend that summer there.
Gotcha. And I guess the rest is history, or the history still being written after that moment, basically. It's funny because when you mentioned Microsoft Office, like at first I was like, oh yeah, the office in Seattle, like, or Washington. Out there I was like, yeah, that office. But then you were talking about the suite.
Right, yeah.
Microsoft Office.
I was working on Microsoft Word.
That is so cool. Maybe, I don't want to dive super deep into like everything behind it, but my curiosity, what was it written in? C, C++, I'm assuming. Visual Basic, I have no idea what exactly was Word or your code base you were working with back then.
Yeah, it was C++. And it was, the one notable thing that I remember is the code base was so big that at the time it actually couldn't fit into Visual Studio. And, Visual Studio is the Microsoft IDE, which is, I think quite scalable overall, but it could not fit into Visual Studio, so we had to use some random other IDE for it.
That's such a fun fact. Especially now people assume Visual Studio Code is like the standard nowadays, but before then there's Visual Studio, which is non-code version of it, and I think a lot of it nowadays was mostly for C#, if I got that correctly.
Yes,
a lot of that development is done on Visual Studio. The fun part, though, Cloudera. I'm aware of Cloudera, funny enough. Not only because I used to follow its stock, which is quite fun, but also I think they had a meetup somewhere in London, maybe, and I was working in London at that point, and I think they happened to have a meetup over there, so I ended up going. So that was really, really cool. But you already described briefly of what Cloudera is already, but this is the part where I'm so curious of how an engineer, right, a software engineer working on whether it's Microsoft Office or any kind of like web stack or anything like that, the transition is to data. I feel like sometimes it goes the opposite way, like the opposite of around, where a data scientist, data engineer goes into software engineering more generically. But this is the part where what brought you? I know you were already saying that you had the curiosity, but was it a side project that brought you? Or was it like a project at Cloudera that needed somebody to look more at the data part? What was the factor that dragged you into the data side? Because what you do today is so data heavy that maybe this connection is fun to hear.
So I think for me, it was very self-motivated at the time. I think I had taken machine learning courses in college and kind of like read stuff about machine learning, had like an interest in it, kind of kept up with it, and basically thought it was cool and wanted to do it. And then I think aside from like the technical excitement of machine learning, Cloudera had all these customers that were companies in the world. And those companies were like doing stuff. It like somehow felt very real. Like what I was doing at Cloudera was cool, but it felt very abstract. If I was making MapReduce take 5% less memory, it was very hard to connect that to something that was happening in the real world. But if I was helping some, financial institution understand risk better, I guess that's also a little bit abstract. But it's, at least from my perspective, that felt like a little bit more real world. And so I think what was partly exciting to me about working with data is getting into this more applied mindset.
That was a perfect analogy from how people understand the term traveling salesman. It's because you could relate to understanding, hey, it's a physical body or physical person having to knock on so many doors as short amount possible. Like when you're talking about this applicable part, is of course there's so much theory behind it, there's so much algorithms behind it, so much loops behind it for sure. But what you were saying, how it's you have these clients of Cloudera and all these customers that are using it that have real problems that they're solving, and your
right.
technical aspect of coming into it, that was such a good analogy that I really enjoyed.
Yeah, and later in my career, when I ended up working at companies that were closer to the real world, I actually had really found it fun to sort of directly interact with people using our software who had very different personas than the typical software engineer. Like for example, I was working at this company called Remix that built software for transit planners, and so going and talking to bus drivers and the people who schedule bus drivers, it's just this totally other shift that makes you really feel the material impact of what you're working on.
And that's why I think a lot of people enjoy tech, not because of just the money at the end of the day, but also the fact that you are participating to a lot of these solutions that you're building at the end. This is probably a great time to ask data scientists, data engineering, what does a data person do at the end of the day? Like software engineering, right? We get a bit of code, we get an IDE, we get to deploy it, compile it, deploy it, all that kind of fun stuff. But what is maybe more popular nowadays? Because as you were saying, back then, data science wasn't that defined. It wasn't a field that is here's a textbook of exactly everything about data science and everything. So maybe this is a good part in terms of how would you describe a data scientist from, I guess, that period? Because I guess if you want a layman term from Perry's layman sort of engineering non-layman term is data scientists not exactly building the pipelines, not exactly building all the warehouses, not exactly building everything, but they would be the ones looking into a lot of data and figure out patterns, whether they do directly SQL and they just sort of a bunch of SQL to figure out what is, I don't know, the revenue for this month or something like that. I feel like data scientists and data analysts are closer than data scientists and data engineering, and this is maybe where I'm wrong. This is maybe where I might have not the right perception of what this is at the end of the day. So I just want to hear from you, even from back then, and you can even compare it to today if you want, but data scientists, because I believe that's what you would coin that. What did a data science do back then? What did they code? Did they not code? What did they work with? That's something I'm so fascinated with.
Yeah, I think as you alluded to, this term data scientist has, shifted around and taken on a lot of different meanings in different periods. There was like the definition of a data scientist as someone who kind of bridged this world between statistics and engineering. And that's kind of like a very skills-based way of looking at a data scientist. Like, what do they know how to do, as opposed to like, how do they spend their day-to-day? I think, it's shifted to mean something that means something probably a little bit closer to data analyst. So someone who is, whose primary job is to answer questions with data. And that often, sometimes requires using math and statistics, sometimes does not. Maybe zooming out to your larger question, the term that I kind of find most useful to use is data practitioner, to be this larger umbrella of all these different roles. And I find that useful because there's so much overlap between what people do. I think many analysts and data scientists sort of are naturally working as data engineers, just because that is an important skill set, an important set of duties to like achieve their goals. And then vice versa. So like kind of thinking about the core things that the data practitioners do. There's the answering questions. So someone needs to make a decision, or someone needs to understand what's going on in the world, just to build context. They'll maybe allow them to make a decision in the future. And someone needs to look at the data and figure out what's the right way to take what may otherwise be a somewhat nebulous or ill-formed question and turn it into something that you can actually directly ask data. So that's like an important job, an important skill set. Another important job and important skill set is data engineering. And so data engineering, the way that I would largely define it is building data assets. So you start with data that's in some format, in some place, and your job is to take that data and create new data assets that are often in a different format in a different place. And why would you do that? Normally because that new format and that new place is more convenient for the set of tasks that you need to do with it. So the newer format makes it much easier to ask certain questions of that data, or it powers your application. So maybe you're taking data and you're shifting it around, transforming it, aggregating it in a way that it can now be a part of a production software application. That the one I always think of, it's like, there's 2 bajillion, but you go on Google and there's they tell you how busy it is at each time of day at a restaurant. That's sort of like a lot of data had to get engineered in order to tell you that.
No, I think people just mark check-in and that's how they get their graphs from. It's definitely not like that. It's definitely
yeah.
No, I was gonna say that's a good example, because as you were saying, like, it's pattern recognition. It's a lot of maybe like, I don't know, some linear behind it to make sure that, hey, we're not lying to the people using that. So that's a really good tool that people could refer to in a sense of understanding what you could build with this skill set of data engineering and data science at the end of the day. I will start using the word data practitioner way more nowadays, moving forward, just because I feel like this is just Perry's opinion more than anything, is people think that the gap of jumping into data is like massive, right? It's like you got to spend 7-year courses doing whatever XYZ. But the thing is, like, people practice data. Engineers like practice data like on a day-to-day basis. And it's just that gap is more maybe like a misunderstanding, if anything. Not saying that data scientists and data engineers and everybody in data, even ML engineers are very close to software engineering. I just feel like it's not as daunting, and we're all working with fun technologies on that.
Yeah, no, it's a total continuum. And yeah, the thing I didn't even talk about at all, which is important as well, is the whole modeling and machine learning side of things, which is basically, it's a kind of fancy form of data engineering where like the data products that you're building are not just data sets, but they're actually models that can be used to answer questions on their own. I think that I've just, in terms of what I've observed in my career, the titles have a very loose correspondence to the actual things that people are doing in their jobs.
Yeah, that call out is great, just because even from your story, like we obviously dive into the data science part, and then you've done some product management after that at Remix, I believe, and that's really another perspective of you've already got this I guess like this touch with data, but also connecting it to users, connecting it to other business stakeholders. Like, of course, that's where a lot of great talented PM comes in, where you're able to make this connection. So I definitely enjoy how you have that path with you. And then after, you also jumped back, I guess, more into closer to the technical side of doing a bit of engineering management, and I'm obviously doing a lot of engineering on the ML side, which is why what you just mentioned about the machine learning is great, because I feel like if you culminate all of that, that does apply to the beginning of the story of Dagster Labs, how you joined them, just because even the word you already dropped, the data assets. Guys, remember this word, because we're going to be jumping definitely into a lot of those references over there. But getting to the point of joining Dagster Labs, thanks for the preview already of mentioning like what you were frustrated with and the pattern of people building their own tools, whether it's framework, whether it's a very simple command line tool. I'm guilty of it. My two proudest like open source projects, it's tiny. It's just tools that, it's not data related, but it's tools that I personally was frustrated. It was a password generator that I wanted from the command line. I do not want to use like one password. I don't want to click like 7 billion times. It's one thing. I wrote it in Golang, whatever it is, it's out there. But I feel like that was some of the sentiment of when you were working with data and getting all these like maybe visual aid or other parts to it. So when you got into the conversation with Dagster Labs, was that the intention? You joining as, or what was the intention basically? Were you joining as more of a data person or like an engineer? Like that's really what I was trying to figure out there when you joined Dagster.
Yeah, it was interesting. So Nick Schrock is the founder of Dagster Labs. He is famous for having created GraphQL at Facebook prior to that. And so I met him a couple of years before I joined Dagster Labs. I think at that time I was a product manager, and he was kind of in the very early stages of founding the company, and trying to learn, number one, from people who had been data practitioners, and then I think separately from maybe product managers, people kind of who had that perspective, and we just kind of like became acquainted. I had told him about some of the stuff I was working on, and I was working at Keep Trucking at the time, which was this, now it's called Motive. I was a data science manager, so that's one of the companies where I was like, technically a data scientist, but working a lot as an engineer. And I had kept up with Nick through that time, because he was trying to stay in touch with people who were doing data engineering. The project that I was working on at Motive got canceled, and I was trying to figure out what the next thing was to do. And I was like, kind of had this moment of like thinking about, okay, what do I actually enjoy in my career? Like I went out on this big journey to be a data scientist and to like, be exploring data. But when I kind of looked back on it and thought about all the like moments in my career when I was having the most fun, it was normally when I was building something. So the moments when I was having the most fun were not when I was trying out different hyperparameters to make a machine learning model as performant as possible. And it was not when I was sort of thinking through a hard business problem and trying to, figure out the right way to present data in a way that it was answering it. It was like when I felt like I was building something that was reusable and durable and engineered in some sort of way. And basically concluded that I wanted to go back to being an engineer, or at least try it out. And so I think throughout the time I had been doing enough engineering as part of my job that it wasn't like picking up this entirely rusty skill set. So when I joined at Dagster Labs, it was as an engineer, not as a data person. Long story short.
No, I mean, the longer the better, if anything. Because I mean, like, that's extremely helpful. Because when you think about it, is that the data world, there's different parts to it of who knows what. And what you do, what you contribute at the end of the day is it matters. It's crucial at the end of the day. So whether you contribute on the product side or even like the data side or the engineering side, you coming in as the engineering side of understanding, hey, you could build this, you could build that. Before I dive super deep into like what you've built there so far, is maybe the explanation of Dagster Labs. I've played around with it. I've seen the tutorial videos. It's cool. But the thing is, like, me describing it as cool, it doesn't do it justice. So maybe from your perspective of maybe what's, I guess, the most popular product of Dagster Labs in a sense of who is it catered to? What does it do? And I'm sure it's going to lead into how does it solve a problem? But yeah, maybe for the layman like me out there, what is Dagster? Or what is the product? What is the main product of Dagster?
Totally. So Dagster, that name refers to an open source software project which is the core of what we're building at Dagster Labs. We build that, and then we build essentially a proprietary product on top of it that's called Dagster Plus. That's a hosted version of Dagster plus some additional features on top of that. But I think we can, when I talk about what we build at Dagster Labs, we can basically just talk about Dagster and use it as kind of if you squint enough, a word to describe the things that we're building. Dagster is software that helps data practitioners build data pipelines and then build the data platforms that contain those pipelines. For that statement to have meaning, it probably requires me to give some definition of a data pipeline. And I alluded to this a little bit earlier, but ultimately a data pipeline is something that's responsible for taking data assets and producing data assets. A kind of super simple example that I often start with is, let's say you run some e-commerce site and you have your website, you have your application that is responsible for serving that website. Somewhere deep in that application, you're going to have maybe a couple tables. One table will be an items table that will just have a list of all the items that you're selling on your website. Another table will be an orders table that'll be a list of all the purchases that people are making on your website. And then maybe also like a users table that lists all the people that make purchases on your website. So you'll probably start with these in some sort of transactional like OLTP database. Maybe it's Postgres or MySQL or who knows what. So at a certain point, someone in your organization starts to ask questions about this data and starts to kind of think about ways that this data could be used in ways that are sort of maybe more exotic than literally just displaying the products on the website. So let me give a couple examples of what those questions might be. One might be, how are our sales doing? Do we sell more stuff on our website this month than last month? Another thing someone might ask is, wouldn't it be cool if we had a recommendation feature on our site? If whenever one of our users logged in, they could see a set of products that we think they would like. And so to answer these questions and to build, these kinds of features, you end up needing to kind of exit the world of your application and enter the world of your data platform. Your data platform is just basically the place where you store and process data, kind of independent from the operational sources where that data is generated. To answer these questions, and to, let's say, build this recommendation model, something you're going to have to do is probably build derived data assets. So you don't want to do kind of heavy computation inside your operational database that serves your application, because number one, that's going to slow down your application, and number two, that database is not even built to do that kind of computation well, and it's going to be slow and take a long time. So probably the first thing you'll do is have some sort of step in your data pipeline, as we call it, that takes data from that application database and moves it to some other system. So the other system, it might be a data warehouse, it might be a data lake. Ultimately, it's something that is kind of built to store ideally unbounded amounts of data and to allow the kinds of processing on that data that you want to do in order to generate the data assets that are going to come later. Once you've got it there, it's very likely that the way that your table is structured for your application database is not the ideal way that you want it to be structured in order to be doing machine learning on it or be doing these analytical queries or answering these kinds of questions. So you're probably going to have to do a set of data transformations that are going to take that data and produce kind of further derived data assets that are better fit to these sort of these data use cases that you want. So you might aggregate it, you might join some stuff together to create nice denormalized tables for analysis. You might do some degree of feature extraction. And when you sort of start to put all that stuff together and zoom out a little bit, you have what is a graph. When I say graph, I mean in the kind of computer science sense of a network. You have a graph of data assets. The source of that graph is the data in your production database, and then there's data assets that are produced in your data warehouse from that production database. And then there's kind of on and on and on. You have, the edges in this graph are like, I derived this data set from this other data set. When you talk about a set of, the term data pipeline, it basically means like kind of like this graph. Like the boundaries between data pipelines are often unclear. But what we really mean is this kind of like often organizational wide graph of data flowing from asset to asset. And so Dagster, coming back to what Dagster is a software that helps you manage that graph. It helps you define these data pipelines. So write code that says this table is generated from this table and has these properties, and this table is generated from this table and has these properties. Show it to you so you understand what you wrote, execute it for you, and do that automatically at the right time.
I think this is so cool because especially how you took something that is very understandable, right? The sales team or the business stakeholders to be like, how many users we have on this website? Or what if we could like funnel half of them to there? We have to make decisions, recommendations, and all that. You need to be able to compute this logic at the end of the day. And then how do you do that? You take the data, you feed it into a pipeline. And the coolest part is towards the end, Dagster, and when you're mentioning all these graphs, right? This directed acyclic graph, DAG, if I got that correctly.
Exactly.
That's part of the name, is it? Dagster Lab is because of the DAG in there.
That's exactly right.
Just because I had to explicitly ask it, or else I wouldn't know about that. But everything that you made sense, because like from me as an experience, a person who have experience with working with data from the engineering side, is managing all this is not impossible, but like you have to know that XYZ is living in Tableau. Not even Tableau, that's way down the pipeline. Like XYZ is living in this table to begin with, and next thing you know, you either use some service like Stitch or something to like move something to the other, and then next thing you know, it's like, oh wait, we use Snowflake here. We don't use like some other data warehouse. And for me to be like, of course, it took me years to be exposed to so many different things to understand it. And then imagine a person needs to manage all that without a tool that lets you do it. That's why I got so sucked into Dagster and Dagster Labs and everything that got built to it. Because visually, obviously you guys can check out on the website. There's a lot of demos, and if you just install it, very Python heavy, which is basically the whole data world nowadays, which I have no complaints about. One thing that is really cool, I guess, is I want to think about it in terms of how development happens at Dagster, right? Because there's of course the community and the open source, and we're going to talk about that just because the community is so important for this kind of project. But on the technical side, the way I describe myself, like I'm a product engineer. We have product features, like I build product stuff, whether it's mostly on the web stack and everything. But software engineering is a little bit bigger than that, right? There's like infra, there's security, there's DevOps, and all that kind of thing. So maybe from Perry's very geeky perspective is the development at Dagster, but even at Dagster Labs, what would you consider that as? Do you also have product engineering, infra, DevOps, security, like data engineering, machine learning engineering? Like, what would you describe that as? Because the product itself is cool. Like, that's what I know, at least.
Yeah, that's a great question. That's a fun question. So I think kind of answering that question where I immediately go is like, what are the components of Dagster as a system? And then, the components of the software that we build at Dagster Labs. So one of them is Dagster's Python API. This is the kind of user accessible framework. So a user wants to define a data pipeline using Dagster. How do they do that? That's the part of Dagster that I work on the most, although I kind of jump around in the stack. Once you defined a pipeline in Dagster, you are then, you sort of tell Dagster about it. So there's kind of like this interconnect layer where we take the objects that you've generated in Python and generate kind of like serializable versions of it that we can send to the Dagster, we call it a host process. And so a host process is a place where Dagster users aren't sort of running their own code, and we're only running code that's written as part of the Dagster project. Dagster has an open source version as well as a hosted cloud version. Both of these versions, run what we would call a host process code, which is the code that's like not user defined. And so, the main host process that we have is the Dagster web server. And so if you're working on the Dagster web server, that's kind of classic backend engineering. Dagster is backed by a database. And so like fundamentally what the Dagster web server is doing is receiving, communications from the front end and via GraphQL and then satisfying those requests and those queries by going to the Dagster database and querying the data model and giving stuff back. So that brings us to the front end, which is also another component of Dagster. And the front end is, everything that's responsible for displaying DAGs, helping people operate their data pipelines. Let's see. Okay, then there are, all these other backend-y components. So Dagster, a big part of Dagster is the scheduler. Dagster, it's not just an app that you can look at. It's something that you can say, even when I'm not there, run my pipeline for me. So we have host process code that's responsible for doing that. And that's also kind of in the backend space. Those are the main components of open source Dagster. And then as a cloud SaaS company, there's also a bunch of stuff that involves basically like running our platform, running our hosted platform and the infrastructure that backs that platform. And so we have a platform team who's responsible for kind of stewarding and shepherding our storage, which involves storing metadata from all of the users of Dagster Plus. And then there's also just the, web infrastructure and, elastic scaling and all of that, all of that set of components that allows people to use our product, not have to host it themselves.
That was a phenomenal answer. I feel like that's the first time I've said the word phenomenal answer on this show, in the sense of it was so digestible, everything you meant. Not saying that, yes, don't explain their answer correctly, but this is something that I felt so related to everything you mentioned in terms of there's so many pieces to it. And the best part is that the user, the intention at least is the user, doesn't have to worry about all these different components. They just have to worry about whether the API, it just works. And that was one of the cool things that when I talk to people like you so involved into building these projects and everything, is that you're able to pinpoint the different parts. I'm like, oh, that's where that's what powers that scheduler. What powers that cron job that does XYZ kind of thing. I absolutely geek out on these topics at the end of the day. One thing that I might ask actually is, one thing that, of course, people worry about with data is performance, or even just how are you even able to move 90 terabytes from one side to the other? The story is Amazon has these trucks, AWS has these physical trucks that shows up with data centers in quotation marks.
A bunch of hard drives in there.
Yeah, and they protect the hell out of it, and they make sure that they make it to their destination so they can unload or download everything back into some server. So performance has always been a concern. Well, not just performance, just large scale stuff. So I guess for Dagster at the moment, I'm sure you guys have tested many different scenarios, but maybe what concerns do you guys have, or what do you guys usually? Maybe it's a trade secret, I don't know, but it was kind of in the sense of there's stress testing for web servers, for example, right? That's the case where you could just bombard it. I don't think that's a great word, but you could just spam it with a bunch of requests and see how that works. So in the, I guess more of the data side of the world, what are practices that people do to make sure that it performs?
Yeah, and the first thing I'll say there, which is a bit of a sidestep, is that to some degree, when people talk about big data and processing enormous amounts of data, to some degree, it's not our problem. And the reason that's not our problem is that ultimately Dagster is an orchestrator. And so what we do is invoke code that executes in other systems to process enormous amounts of data. So, you might have a SQL query that when you run it in Snowflake or against Databricks or whatever, is using thousands of machines to process terabytes of data. But from Dagster's perspective, all we're doing, we have some thin process, and that process is just, running the code that invokes that SQL query. That said, we do face a set of performance problems of our own. So Dagster is a metadata store for data. And kind of the dream of Dagster is that everything that's happening inside of your data platform, every time you update a data set, every time you record some information about a data set, how many rows it has or something like that, that's stored in Dagster. And Dagster takes this approach of having an immutable event log. So the idea is that you should be able to kind of look back, replay history at any time. You're never losing context about what's happening. Whenever something occurs in the system, it's not an update, it's just an append to our logical event log. Early in Dagster's initial architecture, we sort of took the idea of an event log quite literally, and we actually have this blog post about using Postgres as our event log. Over time, that has run into scaling problems, as you might expect. Like using Postgres as a enormous immutable event log and kind of like querying that event log directly anytime that you want to answer a question on the website is very challenging and very slow. So the direction that we've evolved in is basically to create a set of views on top of this event log. So you don't actually have to query this massive event log every time you want to show something in the product. You query some derived attribute of that event log that is maybe cached and maybe more directly answers the simpler question that you want to ask.
I think this is so cool. As in, like, I feel like I knew this, but the more clarity that you bring into this, it just gives more confidence. I'm not a data person, but everything that we shared at the end of the day, it makes us understand how we use our data properly and how you guys actually solve these problems, right? Like, you attempt stuff, and then you realize that, oh wait, there's a better way of doing it, or maybe that's not the right approach. So I love this topic of performance, especially in your world, of you and Dexter's world of data and everything like that. This has nothing to do with data, Dagster, but this is probably like a data thing where sometimes with stakeholders, when they look at like derived data, they're like, but these are old data, I want like live data. I'm like, what world do we live in where you can have like massive computation on, like, maybe one day, don't get me wrong, maybe with the quantum stuff or anything like that, but I know I'm going on a bit of a tangent, but I feel like you might have heard something similar over the years.
I think it's a question that the whole data infrastructure industry kind of asks itself periodically, is this going to be the year or like the decade or the century that we move from batch data processing to streaming or real-time data processing? And I think there are many companies that are sort of built on that hypothesis, or at least built on the hypothesis of moving closer to it. So far it hasn't panned out. And there's probably a lot of different reasons for why that is. I think one of the reasons is that for a lot of things, people actually don't care about data being real time. When I go to Google, I want to see how busy it is at a restaurant I'm thinking about going to. That's a case where I do care about real time data. But if we're trying to figure out whether our sales figures for this quarter, how they compare to the last quarter, in many cases, waiting a couple hours to get that data isn't actually going to make a big difference and is not worth the trouble.
Yeah, as you were saying, like the effort to get that feature, is it worth the time spent to build something, and what's the benefit of doing it once you have it? That's definitely a good business question to debate on, if anything, on that. One thing that I definitely want to make sure I ask you, because I don't always get the opportunity of seeing such big, large open source projects and people being involved on the tech side. Because once you have fairly large open source projects, the issues start coming in, the pull request starts coming in, the even just the comments, the topics, the conversations come in and everything. So I feel like from that perspective, I'm assuming that you do participate into a lot of those like conversations and keeping track of what's right, what's wrong. And I feel like this part that I was just saying, what's right or what's wrong, that's always been the mystery to me. So maybe from your perspective, working in such an engaging community, and don't get me wrong, that's a luxury. Working with an engaging community is an absolute luxury out there. What does that look like? How do you manage that? How do you figure out what's right, what's wrong? Like, maybe my question is a bit shallow, but it's kind of trying to figure out you guys' perspective on this.
Yeah, we are very lucky to have a very engaged community. New issues are coming in all the time, new GitHub discussions, new requests. I'm lucky to be able to spend a lot of time just talking to members of our community. So something that happens a lot is someone will file an issue asking for something, and then they'll get a DM from me being like, why do you want this? Let's talk. It can be difficult because, we have a limited engineering team, and, the set of people who use the product is a lot larger than the set of people who have the bandwidth to contribute to the product. And that means there's a lot of telling people like, not now, or wait, etc. But on the flip side, it creates this kind of glorious feedback loop. when I think about kind of like developing new features at Dagster, there's kind of like this liftoff point where at the beginning you're hypothesizing that something might be useful. You're like floating it to people. Maybe there's a few like disconnected issues that people have created in the GitHub that sort of point to the same underlying need, and you're kind of like tracking those people down and learning more about what they want. And then you get to a certain point where it's like people are using it and they're like, oh, they take it for granted, which is great because that means that it's useful to them. But then they file sort of requests that are very straightforward. They're like, oh, I use it, but it doesn't work with this other part of the system in this obvious way, and that needs to be filled in. You get to this point where it's kind of like this flywheel of like, okay, user needs something, fix it. Next user needs something, fix it, and you kind of expand and get to a mature piece of the product.
Yeah, I really like that perspective, just because you never want to discourage somebody from participating and from giving their feedback, because that's right. What you want. And being able to have so many requests and making sure that people do get heard, I feel like that's really the important part of, managing a roadmap, number one, and then also being able to address like the community at the same time. These are all questions that, like, me as a person that probably doesn't have any business trying to worry all about this stuff, I just think a lot about it, and I'm glad you shared a lot of it from the Dagster's perspective on this. One thing that I think is really cool to think about, this is more on the human side, I guess, is more, you definitely see people of different years of experience, different, I guess, age of experience, and different kind of exposure of experience working with such a product, whether it's on the software engineering side, whether it's on the data side. So one thing I do want to ask you, in the sense of what do you notice? What's the evolution as a human working with a product like Dagster and on the engineering side or even the data side? Like, what do you see that is different between somebody who just got exposed to it versus somebody that have worked on similar data product for a while now? Because I feel like I have an answer, but I definitely want to hear yours on that.
Yeah, I mean, first of all, I would say you bringing that up, like, that's the number one challenge that we face, is the fact that our users kind of have different levels of different levels of skill, different appetites for complexity. On one hand, you want to build something that's like mega simple, so that someone who has simple needs can get started and just understand it as quickly as possible. On the other hand, you want to build something that's mega flexible, because ultimately, like, if Dagster is going to get used in organizations across the world, it needs to support the incredible range of things that people that people do. And so it always creates this tension. I think the ideal that we talk about and strive for is this notion of like gradual disclosure of complexity. So simple things are easy, complex things are doable. And I think when we're designing features, there's all these tiny decisions that like determine whether complexity is gradually disclosed. I'm sure there's many places where we've done a poor job at this, and our users are very vocal about that when we do. Either telling us that some simple thing that they wanted to do is too complicated and that it was too difficult for them to figure out, or that some complicated thing they wanted to do was impossible. And so it's a constant balance of those forces. So I don't know if that 100% answers your question, but it definitely answers the question that's very present in my mind.
I mean, it definitely does. And in my perspective of like, you want to cater to everyone, right? You want to cater to everyone for every level of experience. And you want to be easy to adapt. And that what makes it appealing at the end of the day. And I know it's a hard question, not just for the Dax product, but just in general, like how to find a good level of middleness to capture everything. That's something that even Hannah Montana just wants the best of both worlds. From that front, though, I like the perspective of when we talk about humans in general. Sandy is a human at the end of the day. What helps you do your job? What helps you do you, in the sense of, I'm a techie guy at the end of the day. What's like your favorite applications? Like what are some phone apps or computer apps that you cannot live without? Like, some people would be like, whether it's a note-taking app, some people would be like, I definitely need Slack. Like, I can't live without Slack at this point. So maybe from your day in, day out, day to day kind of thing, what are your favorite technologies, applications that you use constantly?
Yeah, man, let's see. We use Slack for internal communication. Love it or hate it, it is it is the water that we swim in, and I would say probably a little bit more than I hate it. Would say the same thing about Notion. If you follow me on Twitter, I'm often kind of raging at Notion's behavior and ways that I doesn't meet my expectations of it. But I also spend all of my time in it. Let's see. My editor is Sublime, which is, I think I'm the only person at Dagster Labs who uses Sublime. Almost everyone else uses VS Code. I tried to make the switch to VS Code. It was just too slow. I got a new laptop. I was, it was like the M1 and the, early M1 days. I was like, all right, I got a fast computer. Now I'm just going to switch to VS Code. Going to be like everyone else. It's going to be awesome. And I did it for 2 weeks. I tried my hardest and I couldn't do it. And I'm back to Sublime. I talked to AI about, the biggest thing is about names. So, I rarely use it for coding because it doesn't really, understand our code base. But it's often I'm trying to name a new concept and I needed to help me brainstorm with a set of things. It's oh, it's like this, but it's not, it's not like this. And so I'll talk to ChatGPT about that stuff.
That's a great use of it. I don't think I've heard anybody use it like that to have this naming this concept, putting more colors to something that is so nebulous. That is absolutely cool. And of course, big shout out to Sublime. People, I don't know if people appreciate it. I know it's free and everything. I know you can always buy the whole thing, but Sublime is amazing. Every time I have a non-techie person, I make them install Sublime for the sole feature of Command D. If people don't know Command D is, it highlights the same word multiple across the text and you can edit all of them very quickly. I've shown this trick so many times, and you have to send me your config file for Sublime. I've tried to use
that reminds me of another piece of software, but go ahead.
Yeah, I'll finish this thought in the sense of I've never managed to get a good config of trying to get all the repo or the paths and everything correctly. I don't know. I'm forced to either use VS Code or if I'm I have the luxury, I use WebStorm for a lot of web dev for a lot of that, but Sublime is just so quick. It's just so good. It's the one that beat out Atom. It's the one that beat out Brackets. It's the one that beat out all the other old ones from back then. But yeah, one day on the config file. But sir, you're mentioning.
Oh yeah, first I was gonna say I command D 2 billion times a day. Command D is my life. I use a Carabiner, which is a Mac keyboard remapping tool. I've heavily remapped my keyboard. I had a lot of wrist issues in my right hand for a while, so I basically do everything on my all my sort of control stuff on my left hand in this crazy way. I could not live without it.
That is a good call out. If you do happen to have dot files, feel free to share it. I'll link it as much as I can because I feel that's the thing that people love sharing. This is probably the last question, if anything, but I love this part where you are a contributor to Apache Spark. I've dug a little bit into it. I believe I found your first commit. Do you remember what was your first commit to Apache Spark?
Oh my god, pop quiz. I do not. Do you have it up there?
I have the link. Of course, I'll send it to you. But it feels I'm not super familiar with the code base itself, but it looks like a test case, if anything. It looks like it was a bit of Java and there's some tests, and then you managed to get something into it.
Proud of myself. It was a test case. Test-driven development.
I know, right? If anything, better than a comment. Nothing wrong with improving comments, but I will definitely send you that link because it was a fun discovery, if anything. And thank you for contributing to open source software at the end of the day.
It's been a while since I've worked on Spark, but it was very fun software to work on long ago.
One thing that I do also want to close off with this one is you've definitely seen a lot of tech. That's one thing that I could say. And in the sense of what, I guess, advice would you have for people, especially in this gap of data science, data engineering, software engineering, maybe a bit of infra, or even kind of just this ML pipeline of everything, whether it's somebody just at the tip of the iceberg getting into it, or even maybe somebody who's been there for maybe a couple of years, what general advice would you have for people just looking at this this beast, this industry, and how to keep the excitement? Because I definitely hear the excitement that you have this joy of working in it. So what could you say about that?
The data industry is definitely a roller coaster in terms of tools. So getting attached to any single technology, SQL will probably always be there. So learn SQL. But getting attached to any single technology is probably not a winning strategy. Let's see. I think that overall, engineering skills go a long way in the world of even like data science and analytics. I think no one kind of wishes they spent less time learning how to like do some basic coding and some basic abstraction in that world. I think also the world of data kind of lends itself very well to like functional programming and functional ways of thinking about things. One thing that I've sort of like, this is like a very random thing, but like one thing I've sort of noticed among people who are sort of getting into software at the beginning is they'll get very excited about like object-oriented programming as a way to like be, do real software engineering as opposed to like, just data munging. But I think often object-oriented programming is not the right approach in the world of data. And then kind of on the converse side, I think being very willing to engage with the domain is very important. It's easy, especially if you come from an engineering background, to kind of want to stick to the world of abstraction. But actually, like being successful, like building data products, building data assets, solving data problems often requires just like doing the dirty work of like understanding the real world the data is trying to model. And I find that very rewarding when I get in the mindset of engaging with it.
Yeah, the tangible part of it, the part you could grab, the part you could show to people to be like, this is concrete. Those are absolutely great advice. Great look up. Great, hey, here's what's exciting about this world kind of thing. And I really appreciate you sharing all of that. Where can people find Sandy? Where can people find Dagster Labs? I definitely do know you're active on a couple of different things, but yeah, I definitely would want people to see more of you and hear more of Dagster. So where could people find you and the team?
Yeah, so I am S_RYZ, SRiz on Twitter. You can also just find me on LinkedIn, Sandy Ryza. Check out Dagster.io. That is our website, or github.com/Dagster.
And of course, all the links will be shared in the description notes down below, and I will definitely be mentioning those multiple times. But honestly, these were amazing stories. I think from cover to cover, like even the preview that we gave us at the beginning up until the point where you dived super deep into like data and the derived data and everything like that. On behalf of myself and everybody, just want to say big thank you for being on the show.
Thanks so much for having me, Perry.
And for the rest of you, I will catch you on the next one with even more fun stories. But thanks again. I'll see you around. Bye. And that was Sandy Ryza, lead engineer at Dagster Labs. All the links are shared in the description notes below. Go check them out. If you would like to be on Podcast Room by Software Engineer, reach out to us. Just email contact@perrytiu.com. Can't wait to have you on the show. Once again, thank you so much for listening to Podcast Room by Software Engineer. Don't forget to hit the follow button on your podcast app and leave us a review on Spotify and Apple Podcasts. It's completely free. And if you want to tell your friends about Podcast Room by Software Engineer, that's totally cool as well. Anyways, I am Perry Tiu, and I'll catch you on the next one. Big love.